Okay, so atomic structure. Now, we know that an atom is made up of three basic particles. So I'm going to put this as the atom. So it has got three basic particles. We have got protons, neutrons, and electrons. And that is something that we know like very much. And these two are found in the nucleus. Okay, so we have got the positive protons in the nucleus. Let me put just positive there. And then we have got the neutral neutrons in the nucleus. So I'm going to put N to represent neutrons. So, okay, like that. And we know that electrons are found in energy levels. So we're going to have an electron there that's in a shell. So basically we know that for an atom, protons, neutrons, and electrons, when you get to look at the charge of these, a proton is positive, a neutron is neutral, like it doesn't have any charge, electrons are negative. Another thing that we know for the mass is that protons have got a mass of 1. It's not like they've got a mass of 1. In comparison to electrons, their mass is 1. Even neutrons, their mass is 1. Electrons have got a mass of about 1 over 1840. This is not like it is their mass. It is in comparison to protons. Otherwise, the mass of an electron is 9.11 times 10 to the power negative 31 kg. You are going to understand that in chemistry. It's a constant that you are going to be using in calculations. Okay, so we also know that when we have got an atom can either be neutral or not neutral. And you know that an atom that is not neutral is called an ion. So we're going to have an atom and also an ion. So where can I write an ion? Let me write ion here. Now how do you differentiate this? So you are going to see that for an atom, if an atom has got 7 protons, this means that the electrons are going to also be 7. Remember, protons are positive, electrons are negative. So you have got 7 positive things, you have got 7 negative things. This balances the charge. So when you add 7 positive things and 7 negative things, they are going to cancel. Alright, so you are going to have a charge of 0. Now let's say this atom loses 2 electrons. Okay, it loses 2 electrons. The protons remain the same, but the electrons are going to change. So we're now going to have 5 electrons. So what has happened here? You have got less negative things. Remember, electrons are negative, so you have got less negative things. Because of this, when you add positive 7 plus negative 5, like protons are positive, right? Electrons are negative. You are going to have positive 2. So when an atom loses electrons, it's going to become positively charged. Okay, because you have got a few negative things. And such an ion which is negatively charged, positively charged, is called. I want someone to answer me. What do we call a positively charged ion? Anyone? Very good. This is going to be called a cation. Good, 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 good. Okay, so this is a cation. Why is it a cation? Protons have been, electrons have been lost. It is positive. Now take note of this. Please understand this. These are questions like as simple as this. You'll find a lot of questions just on what you've said here in the exam. Okay, so what happens is that this positive nucleus is going to be attracting the negative electrons. Alright, so the nucleus is positive. It is going to be attracting electrons which are negative, which are found in shells. And because of this attraction, electrons remain in orbit An orbit is simply a path taken by an electron around the nucleus. So the electrons are going to remain in orbit. Why? Because of the attraction between the nucleus and the shells. Okay, now look, when something loses electrons, it means that you have got fewer electrons which are going to be pulled. So in other words, the positive things in the nucleus are a lot, but negative things in the shells are few. I think you have ever played that game where you have got people, others are pulling the other side, others are pulling the other side. So protons are the ones which are pulling electrons. So you have got a lot of protons. Let's say you have got 7 protons. Instead of having 7 electrons, you only have 5. So because of this, there is a greater pool of electrons to the nucleus. How does that affect the atom? The atom is going to become smaller. Why? Because the attraction of the electrons to the nucleus is greater. So you expect positive ions or cations to be smaller than neutral atoms. Please understand this. Cations are smaller than their neutral atoms. I hope that is okay. Do you have any questions before I proceed? Is that okay?
It's okay, sir. No question on my side.
Alright, please be free to ask if you are not clear. Now, let's say, yes, Casey.
Sir, can you kindly repeat on what you said?
Okay, so for cation ions, these are ions where electrons have been lost. So because electrons have been lost, you have got few electrons being put by a lot of protons in the nucleus. Because of that, the atom is going to become smaller. Why? Like you have got a lot of things pulling. Okay, when you have got a lot of things which are pulling, like they're going to pull you all the more. So that is why the atom becomes much smaller. Okay, so if you consider those ions which are, let's say, instead of you having, uh, you know that something neutral, you are supposed to have 7 protons and these 7 electrons, then this is neutral. Now let's say an atom has gained electrons. Okay, so instead of you having 7 electrons, let's say you have got 9 electrons. What is going to be the effect? You are going to have 7 positive things, you are going to have 9 negative things. Okay, so when you get to add this 7 positive things plus 9 negative things, you are going to get -2. So we're going to see that the charge here is going to be -2. Alright, so every time you have got gaining of electrons, there is a negative ion formed. And because of that, this ion, of course, we know is called an ion. Anion. And because you have got a lot of electrons, it means that the protons in the nucleus which are supposed to be pulling these electrons, they are not going to be enough. Okay, so you are going to have 7 protons pulling 7 electrons. What of the extra 2 electrons? Like the 2 electrons which remains, what is going to be pulling them? So there's nothing that is going to be pulling them. And we know that things of the same charge, they do what? They repel. So these 2 electrons are going to be repelling each other. Because of that, the atom will become more bigger. Alright? So what do we say? Anions are bigger than their neutral atoms. Anions are bigger than their neutral atoms. Please take note. This is very, very important for you to understand. So I'm going to move from this principle and explain another principle. So before I explain that, is this okay? Where is Abigail? Where is these guys? Is this okay? Have we understood? Yes, Tom.
Like what happens to the force of attraction between the protons and the electron when it gains electrons? I didn't understand that part.
So the attraction is still there, but the protons are few, so they can barely pull electrons more. Okay, like the electrons wants to be going this direction, protons want to be pulling those electrons, but because there are a lot of electrons than the protons, it's more like the protons are going to be overcome. That's why the atom ends up becoming bigger. Is that okay? Do you have any other question? All right, now this principle, you know that, let me remove this. Now we expand some our knowledge away from this, which maybe would have also known in high school. We know that electrons are found in shells. Okay, electrons are found or located in the shells. Now it is, if I say Tom is located at the University of Zambia, that is just broad. Okay, he has got a hostel. Also in the hostel, he has a room. Okay, so this is how we're also going to talk about these atoms. So we know that electrons are found where? In shells. But these shells have got spaces also. Shells can be divided into what we call subshells. Okay, we know that the other name for a shell is energy level. So the other name for a subshell is also called sublevel. Now a sublevel is also going to be divided into what are called as the orbitals. Okay, so into orbitals. So we know that an electron is found in a shell, but specifically where? In orbitals. So what you have is more like this. You have got, if I say where is Shekinah, you are going to say Shekinah is in Kwacha hostel. This is the hostel where Shekinah is found. But where specifically, you are going to say maybe Kwacha block 4. Where specifically, it is Kwacha block 4 room 9. Okay, you see, so an orbital is more like a specific location. Now, if they asked you to say what is an orbital is simply a region around the nucleus of an atom where the probability of finding an electron is maximum. So it is not a space where we are going to find an electron, but a region where the probability of finding an electron is maximum. Yes, Shekaina.
Sir, can you repeat that definition again?
Okay. So I'm saying an orbital is a space around the nucleus of an atom where the probability of finding an electron is maximum. You can trust me on this one. If you say we want to find this one, maybe let's say you follow your friend at the house. The mother tells you your friend is in the bedroom. So the highest chance might be that your friend is on the bed, right? Especially if you know that there is no table in the room. The highest chance is that it's going to be found on the what? On the bed. But well, at times he might be standing. Maybe he's trying to pick up something. So same with an orbital. The highest chance of you finding an electron in a shell is in an orbital. This is where there is highest chance of finding an electron. So that is what we define as an orbital. Now, this is going to take you to what we call quantum numbers. So these which we are calling shells are described, all these divisions of a shell, including the shell itself, They are described by what we call quantum numbers. Okay, so when you are talking about the shell itself or the energy level, this one, the quantum number which describes this, we call it the principal quantum number. Okay, principal quantum number. So I'm going to use Qn to represent quantum number. And the symbol for the principal quantum number is n. That is why you see n is equal to 1 meaning first energy level, n is equal to 2 meaning second energy level, n is equal to 3. That's a symbol for principal quantum number. That's what represents the energy level. Now, if you go to the subshell or the sub level, which is the division, so each energy level is going to have different sub levels. Okay, so this one is called the angular momentum quantum number. Angular momentum quantum number. So this one is represented by ml. It's actually represented by L, not ml. So this is the angular momentum quantum number. Alright, and then you are going to have an orbital. Now, orbitals are described by what is called magnetic quantum number. Now, the symbol for magnetic quantum number is M with a small l down. So these are the quantum numbers which describe a shell, a subshell, and an orbital. Now, in biology, I'm not going to talk more about quantum numbers. I'm going to talk more about them in chemistry because you also need to understand their shapes and those things. So, how do you find uh, principal quantum number? A principal quantum number is simply the shell. For example, you have got a first shell, second shell, third shell. And then angular momentum quantum number will be a division of the shells. Now, the orbital is going to be the division of the subshells. Now, let's understand this in details because this is what we are going to see being brought, which I'm going to ask you about. So when you have got principal quantum number 1, n is equal to 1, how do you find angular momentum quantum number? We know angular momentum quantum number is L. So L is a number that starts from 0 up to n minus 1. So you can see that n is 1. So 1 minus 1 will simply be 0. So meaning that when you have got n being equal to 1, L will just be 0. Okay? And then for the second energy level, it means that L is going to be 0. It always starts from 0 up to n minus 1. So 0 up to 2 minus 1 will give you a 1. So this is going to be the angular momentum quantum number. If you go in the third energy level, L is going to be 0, 1, 3 minus 1 is going to give you 2. So meaning that L is going to be 0, 1, and 2. Okay? And then for the fourth energy level, n is equal to 4. L, which is the angular momentum quantum number, is going to be 0, 1, 2, and 3. How do you find L? L is always equal to from 0 up to n minus 1. Since n is 4, 4 minus 1 is 3. So we're going to start from 0 up to 3. So this is how you get to find the L, which is the angular momentum quantum number. Now, when you have got the angular momentum quantum number being 0, you need to know this is called an s orbital. Take note of that. Whenever L is equal to 0, this is called an s orbital. Now, because this is coming from the first energy level, we call this as the 1s orbital. Okay? And then still here you can see we have got L being equal to 0, right? Meaning that we are also going to have an s orbital. But since it's coming from n is equal to 2, this is going to be a 2s orbital. And here we also have L being equal to what? 1. And whenever L is equal to 1, this is called a p orbital. And since that is coming from the second energy level, this is going to be a 2p orbital. Okay, when L still is equal to 0 here, meaning that we are still going to have an s orbital, we still have L being equal to 1, that is going to be a p orbital. But we also have L being equal to 2. When you see L is equal to 2, this is called a d orbital. Now, since these are coming from the third energy level, you are going to put a 3 in front. 3s, 3p, and 3d. Yes, now. Okay. So every time we see L is equal to 0, this is called an s orbital. When you see L is equal to 1, this is called a p orbital. When L is equal to 2, this is called a d orbital. Okay, when L is equal to 3, this is called f orbital. When L is equal to 4, this is a g orbital. SPDFG, SPDFG, SPDFG. You just need to know that. I don't know when L is equal to 5. That's not our interest, actually. Not in biology, not in chemistry. It's not your interest. Okay, like you don't need to know that. Just know when L is equal to 1, 0, S. So SPDFG. That's all you need to know. So if you see for the fourth energy level, you have got 0, meaning that is S, right? You have got 1, that is P. You have got 2, that is D. You have got 3, that is F. Now, because these are coming from the fourth energy level, we're going to be putting a 4 in front. 4S, 4P, 4D, and 4F. Is this okay? Do we have any question?
No, yes.
All right. All right. Now, again, remember this is this the n is principal quantum number. That's the principal quantum number or the shell. Okay? N is representing the shell. And then L represents what? Angular momentum quantum number. This one is representing the subshell. So let me say this is representing shells. This is representing subshells. These are the ones you are able to see. These are the subshells. Now I've written them in terms of letters. So when you have got a number, L being is equal to 0, that is S. Now, what of, remember we talked about a shell being divided into subshells and then subshells being divided into orbitals. What of orbitals? How do you find orbitals? Orbitals are given by the magnetic quantum number. We said magnetic quantum number is ml. Okay, magnetic quantum number is ml. Now what I want you to understand for now is that for the for the s orbital, the s orbital can only have uh, 2 electrons. The p orbital, it doesn't matter whether it is 2p, 3p, 4p, it can only have 6 electrons. The d orbital, it doesn't matter whether it is 3d, 4d, 5d, it can only have 10 electrons. The off orbital can only have 14 electrons. Please, this one I want you to know. And I'm going to show you how you get those. Okay. So from here you can see there is nothing like 1p. 1p doesn't exist. Okay? Like for the 1 you only have s, you only have one s. You don't have 1p, you don't have 1d. There's nothing like 1p. Same with the 2. There's nothing like 2d. Okay, there's nothing like 2d. 2d is wrong. Yes, now. And now your hand is up. Yes, you can open your
It
mic.
was a mistake, sorry.
All right, all right. Now, how do you find how do you know that this orbital is going to have 2 electrons? So you use the angular magnetic quantum number. Remember we said the shell is divided into a subshell, and then a subshell is going to be divided in two orbitals. Now the orbitals are the ones which tells you how many electrons are going to be there. So each orbital can have a maximum of 2 electrons. Okay, an orbital can have a maximum. This is an exam question. An orbital can have 1 electron, but the maximum it can have is 2 electrons. And this is how tricky biology questions come. They are going to give you multiple choice. An s orbital can have 2 electrons. It will not have 2 electrons. It will have a maximum of 2 electrons. Take note of that. Okay. Now, how do you find the number of orbitals? How do you find the number of orbitals? You, number of orbitals is given by the magnetic quantum number. The symbol is ml. So how do you find ml? ml is a number that is between positive L and negative L. Okay, that is ml. This is what tells you the orbital which are going to be found in a subshell. Remember, remember, you first have a shell divided into subshells, and then a subshell is going to be divided. Okay, so when you have got L being 0, you don't have the negative and the positive so for 0, meaning that ml is just going to be 0. Take note of that. So whenever L is 0, ml is only going to be equal to what? 0 also. Let me first remove this. I want you to understand this because immediately you understand it, you'll never get a problem. Okay. So when you have got L being equal to 0, remember ml is a number between positive negative L and positive L. Now if your L is 0, meaning that ml is going to be what? Is only going to be 0. Okay, ml is just going to be 0 because you don't have a number between 0 and like you don't have a number between 0. What does this mean? This means that you only have one orbital. Okay, you only have one orbital because the number that you have found is only 1. Actually, this 0 is representing an orbital. So I'm actually supposed to write it like this. It's representing an orbital, and then I'll write 0 here. And an orbital can only have 2 electrons. Now remember, this one is coming from L being equal to 0. And whenever L is equal to 0, we say that is an s orbital. That means that this orbital here you can see is an s orbital. Because it is coming from n is equal to 1, meaning that this is a 1s orbital. If you go to this one, to the second energy level, you can see you have got first n L being equal to 0, right? Meaning that you are going to have, for L is equal to 0, you don't have a number between 0. And for you just to understand this, I'm going to write this in this way, so that even those who have come later are going to catch up. We've said when L is equal to n is equal to 1, you can find L, right? And L is given from 0 up to n is equal to n minus 1. When n is 1, what is 1 minus 1 is 0. Meaning that for L you only have 0, right? And when you have got L being equal to 0, we said this is an s orbital. Okay, this is an s orbital. Now because this is coming from n is equal to 1, meaning that this is a 1s orbital. And what we are saying is when L is 0, ml is a number between negative L and positive L. You don't have the negative and the positive for 0, meaning that ml is just going to be 0. That means that you only have one orbital. Okay, like you only have 0, it only have one orbital, and one orbital can only have 2 electrons. And then for the second energy level, n is equal to 2. This tells you that your L is going to be starting from 0 up to n minus 1. Remember your n is 2. So 2 minus 1 is 1, right? So we're going to start from 0. So we're going to have L being 0 and also L being what? 1. And remember we said when L is 0, this is an s orbital. Because it's coming from the second energy level, this is going to be 2s. And we said when L is 1, this is a p orbital. Since it's coming from the second energy level, it's going to be a 2p. Now, when you have got L being equal to 0, we know that ML is going to be what? ML is the number between negative and positive of L. Now, don't have the negative and the positive for 0. Meaning that ML is just going to be 0. Meaning that you are only going to have one orbital also, okay? So this orbital you are able to see here is the 2s orbital. The 2s orbital can also only have 2 electrons. And then when L is equal to 1, you want a negative, and ML is going to be a number between negative and positive of 1. What are those numbers? Like starting from 1 itself, from negative to positive. So we're going to have 3 orbitals here. How? Numbers. So you start from negative 1 itself, and then you are going to have 0 and then positive 1. Remember we have said ML is supposed to be between negative L and positive L. Okay, if you have got 1, meaning you are going to have negative 1, 0 and positive 1. Meaning that a p orbital has got 3 suborbitals. This explains why a p orbital is going to have 6 electrons, because each of these orbitals is supposed to have 2 electrons. And remember, all these we are seeing here coming from the second energy level. Meaning that this one, 2 electrons, 2 electrons, 2 electrons, 2 electrons. Meaning that the second energy level can have 8 electrons. Okay, 8 electrons for the second energy level. What if you have got the third energy level, n is equal to 3? This means that L, remember L is a number from 0 up to n minus 1. 3 minus 1 is 2. So meaning that L is going to be first 0, L will also be 1, L will also be 2. And remember when L is 0, this is called s orbital. Because it's coming from the third energy level, it's going to be 3s. And when L is 1, this is a p orbital. It's coming from the third energy level, this is going to be 3p. When L is equal to 2, this is a d orbital. And when it's coming from the third energy level, this is going to be 3d. So 3s, 3p, 3d. And if you want to look at the suborbitals in these orbitals, those are we call suborbitals. What number is between negative 0 and positive 0? We don't have any number like that. Meaning that ML, when L is 0, is just what? 0. You don't have a number between positive 0, you don't have negative 0 and positive 0. Meaning that you are only going to have one orbital, okay? So this is the 3s orbital. And when L is 1, what's the negative and the positive for 1? It is negative 1, 0 and positive 1. Like these are the numbers we're going to see. So ML here is going to be, we are going to have 3 orbitals. Okay? We are going to have 3 orbitals like that. One is negative 1, one is 0, one is positive 1. Now, what of when L is 2? So when L is 2, ML is going to be from negative 2 to positive 2. So that's negative 2, negative 1, 0, positive 1, and positive 2. How many are these numbers? There are 5. Meaning that ML for a d orbital has got 5 suborbitals. 5 suborbitals. Okay, these are 5. 1, 2, 3, 4, 5. So meaning that the third energy level, how many orbitals do they have? If they ask you how many orbitals are in the third energy level, they are 1, 2, 3, 4, 5, 6, 7, 8, 9. And remember each orbital should have 2 electrons. This tells you that the third energy level can have 18 electrons. 18 electrons. Okay? And this gives you the formula for finding electrons. I think you saw it in high school, 2n squared. This is how you find electrons. So n is representing the principal quantum number, or the shell number. So for the first shell, put 1 here. 1 squared is 1 times 2, 2. So the first shell can only have 2 electrons. Why? Because it has only one orbital. And then if you go to the second shell, put 2 here. 2 squared, 4. 4 times 2, 8. So I mean that the second shell can have 8 electrons. Why? Because it has 4 orbitals. Okay, like that. Now this orbital, which we call the p orbital, you can see there are three, right? You can see there are three orbitals. Like for p, it doesn't matter whether it is 2p, 3p, 4p, they are always the three orbitals. One is called px, one is called py, the other one is called pz. Okay, meaning that for the second energy level, what are the orbitals in the energy level? I mean the second energy level, we have got the 2s orbital. That's the one you're able to see. Apart from the 2s orbital, we have got the 2px, you have got the 2py, and then you have got the 2pz. This is an exam question. So what are the orbitals in the second energy level? You have got 2s, 2py, 2pz, and 2px. Those are the orbitals in the second energy level. So this is what I wanted you to understand for now.